These are notes 18. We are learning about piecewise functions, something different. This is section 14-3 in your book, which is one of the only sections we'll do in that chapter, so it's kind of just like on its own. Page 930, I recommend that you look in your book. I will be showing it at part of the notes. So make sure you've got your name, date, period. Our essential question today, how do I recognize and graph piecewise functions? And here's a definition. A piecewise function has different rules for different parts of its domain. And that sounds kind of weird. So once you see examples, you'll understand what it means by different rules for different parts of its domain. Make sure you do come back and do questions on the left. So like, for example, right here, what is a piecewise function would be a great question on the left. All right, so go ahead and start copying this down. I do have a little bit of review in case if you don't really remember graphing linear functions. I did write down a little bit, so pause if I go too quick for you, but I'm going to start explaining this. So here's our example. F of x just means it's a function of x. The x values can change, and then you plug in that x value into the whichever equation. So we've never had one like this, where we have our function could be 2x minus 2, and this says for x is greater than or equal to 2, or f of x equals 1/2 x minus 1 for x is less than 2. So it depends on where we're looking at on the graph. If x is greater than or equal to 2, then we use this equation. All right, and then if x is less than 2, we would use this part of the equation. So I put over here a little bit of review. So we need to remember how to graph a linear equation. It would be a line, y equals mx plus b. So m stands for the slope. And then just to remind you, it's rise over run. Rise means your up or down directions. Run means your side to side directions. Positive is up for rise. Negative is down. For the run, positive is right. Negative is left. So it's just like the x and y axes. Up is positive, right is positive, down is negative, left is negative. So that's how you know your rise over run. So that's for the slope. And then for the b, that's your y-intercept. That's a point on the y-axis that the line goes through. So when we graph a linear equation, we start at the y-intercept and then we count rise over run and find another point. Then you can use a ruler and connect the points and you get your line. So that's just a quick review on linear. We'll be graphing linear and quadratic equations for right now. You could have piecewise functions with any type of equation, though. You could have absolute value functions, you could have exponential functions, or even other types of functions. So then I also wanted to review real quick what the inequality symbols mean, because we haven't really dealt with them much at all. So the inequalities are these symbols right here, the greater than or equal to, or this less than. Those are the inequalities. So you would use a closed circle on the graph, like you fill it in, and I'll show you what that would be like if it has the equal to sign underneath. So you would use a closed circle on the graph. That would be the end point. You use an open circle if it's only less or if it's only greater. And I did right here to just remind you less than. It's, to me, I always think of it as it looks like a little L, or like your left hand. Sorry, like that. That's my left hand. It makes that same shape. Your right hand looks like that. So if it looks like your left hand, it's less than. Left hand, less than. Or it looks like an L too. Greater than goes the other way. So that's just a little bit of a review. Closed circle is if it has the equal to sign under. Open circle if it doesn't. All right, so let's get started. Be very careful when you set up your graph. I'm not using graph paper, so I had to carefully draw. I spaced it counting by 2s on every line, and I tried to keep it consistently like spaced out when I marked it here, still counting by 2s. So anyways, pause if you need to. Set it up, make sure you're ready to go. All right, so first, I'm going to graph it's f of x equals, it's the same thing as saying y equals. It's 2x minus 2 for when x is greater than or equal to 2. So what I'm going to do is use pencil first because part of it I'm probably going to have to erase. So when I graph a normal line like this, I would do m equals 2 over 1, b equals negative 2. That's using y equals mx plus b. I start at y equals negative 2. I put my point, and again, I'm using pencil because I'm going to actually have to erase this. My slope is 2 over 1, so from here I count up 2, right 1, up 2, right 1, up 2, right 1. I get a few points so that I can then use a ruler and connect with a solid line. And what I need to do now is I'm checking my domain. So the domain is changed depending on where we're at on the x-axis. It depends on which equation we'll be using. So this one that I just graphed is for when x is greater than or equal to 2. So I'm going to put a closed circle at that end point where it's at 2. So I'm going to go to x equals 2, go up. This is going to be my end point, and I'm making it very clear that that's a closed circle because it's equal to, x is equal to 2. And everything, since this is greater, I also can make that greater into an arrow, and then you'll know it's pointing to the right. This equation will be everything to the right of 2, so I'm going to keep this part, but I have to erase the other part. So I had to use that to graph it because I used my y-intercept and everything, but I don't want to keep that on the graph. So it's kind of like going up and down at 2. It's a division between the first graph or the second one. You can still kind of see it. So let me erase it. Okay, so that's a piece. That's why it's called piecewise. It's a piece of one function, and now we're going to have a piece of another function. Another thing I do is I can also like color code them. So 2x minus 2, when x is greater than or equal to 2. Here's where x is 2. It's a closed circle. I can just trace my line. So I do pencil first, though. I want to make sure you guys realize that. Okay, so now I'm going to graph the second one. I'll just kind of write it over here. Y equals 1/2 x minus 1 is for when x is less than 2. Less than means open circle because it doesn't have the equal to. So my m is 1/2, 1 over 2, up 1 over 2. My b is negative 1. So I just get that from the equation. So I'm going to start at negative 1, put a point. That's my y-intercept. Then I'm going to go up 1 over 2. Up 1, right 2, put a point. I can continue up 1, right 2, or I could, since I'm seeing, oh, this is for when x is less than 2, it's more this way. I can do the rise over run, but just keep going in the same direction, down 1, left 2. So that would actually fit better for this graph. Down 1, left 2, down 1, left 2. And so now you can see this graph is similar to that line, but it's got a flatter slope. So anyways, I'm going to use my ruler and connect these points all the way. Since I'm using pencil, I can always erase it, but I am going to stop at 2 on the x-axis. Where is it? Right there. Got to be able to see your little points. Okay, so there. So I made sure I lined it up. I'm going to make sure I have an arrow right there on the left. The arrows means that the function keeps going forever and ever. Since I didn't extend it past the 2 because I knew it stopped there, I don't have to erase anything. But I can add color to make it look a little bit better. Okay, so that's basically it. Oh, I didn't do my open circle. I want to really emphasize that it's open right here for this one because it was only a less than. So it's, oh. And if you have to make it kind of a bigger circle, that's fine. It's just, we really want to see that you have your open right there and your closed circle right above at 2. Okay, so that's piecewise. That's basically how you do it. Pause if you need to, We're going to also work on this our next day of class to practice a little bit more. But I do have one more problem for us to try. So pause it if you need to or go back. Here is our next one. So for this function, we are going to have a quadratic. It's got a negative, so I can already just imagine it's going to look something like that. It's going to open downwards. And then this one is linear. It's very similar to what we just graphed, except it's 1/2 x plus 2. And the domain is broken up at 0. And I can tell right away this one's going to have a closed circle. This one's going to have an open circle. So there's all these different little parts to think about. So anyways, be very careful when you set up your graph. Space it very carefully. I counted by 2's again, just like that last one. All right, so I'm going to get started. Pause if you need to. My first one is f of x equals negative x squared when x is less than or equal to 0. So I can just write it as a y, or f of x negative x squared. I would graph this using a table. And I would just get a couple points. It's for when x is less than or equal to 0. So I start with 0, and then I can maybe find my values for -1, -2, and I should know the shape of my graph after that. So I can just plug in those values for x. So -0 squared is 0. Then I plug in -1, -1 squared. -1 squared is 1, but it's negative, so -1. Then I've got -2 squared, -4. So those are some points I can use to graph. So I'm going to go to my graph now. And again, at 0, it's like this little division where I'm going to break up one graph on one side and one graph on another. I know you can't really see it, but you want to think about that. Up here, it was at x equals 2. Or one of them's greater, one of them's less, but it's at 2 on the x-axis. That's where the domain is, like, the rule for the domain is changing. So I'm going to plot my points, and this one is a closed circle, so at 0, 0. And then x is -1, y is -1. And then at x is -2, y is -4. So you can see it's like half of the parabola. Remember, parabolas are symmetric. It would go on the other side too, except we only want to show it for x is less than or equal to 0. So I'm going to connect, draw an arrow because it does continue. And that's pretty much it. I'm just going to make it look a little bit better and put some color with it. And that's my work right here. And so closed circle, I really want to emphasize that it's closed, and then just trace it so you can see. Okay, so that's that part. And then the second one, the second function is y equals 1/2 x plus 2 when x is greater than 0. So it's going to be an open circle when I get to the 0, wherever that point is. The slope is 1/2, up 1/2. The y-intercept is +2. All right, so I'm going to graph it. I'm going to start at 2 on the y-axis, and then I'm going to go up 1, right 2. So carefully up 1, right 2, up 1, right 2. That's probably enough, and I could use my ruler and make a straight line. If I'm not thinking, sometimes you're working and you're not thinking, I might just do a long line like that. But then I have to remember this function, this line, oh, I missed a point, but that's okay. This line is only for x is greater than 0, only to the right of 0. So that means like, oh, I need to go back and erase this part all the way to when x is equal to 0. But it's not going to be equal. It's going to be an open circle. And I'll just pretend that point was over here. I don't have graph paper, so it's just a little bit off. Okay, so then again, just to make it look nice, I can use a color and show open circle there. And then it was that straight line right there. Okay, so that's the basics of these piecewise functions. I've had ones where you have like 4 different functions divided across the whole graph. We're starting out basic today so that you can see a little bit of it and get an idea. And real quick, there's just one more thing I want to show you out of the book. So if you don't have your book, it's okay, but just watch and pause if you need to. And again, it's really good if you can just kind of think about this as you're planning it, what your open and closed circles will be like for which function. And like I said, for that one, I was planning ahead, thinking like, okay, it's a quadratic, it opens down. Just make sure that it does look right. So a little bit of planning is always good. Okay, so anyways. So in our book, 14-3 Piecewise Functions, feel free to look at it. We did some of these. You can do some of the other examples if you want a little extra practice. But what I want to show you is this one when you write the function. Oops. So you can write in your book. You don't really need to turn it in. I just want you to kind of see how to do this because we are going to work on this one more day. I see right here how the function changes. So I want you guys to notice how there's one function, then another, that flat across one, and then there's another one right here. So there's going to be 3 different functions. And I like to do this kind of like show the division where it's broken up. So see how I'm drawing the dotted lines down to the x-axis? So I can tell this blue one is for when x is less than -2. It doesn't really have the open and closed circles like how sorry, like how that one has. So I'm not really sure how to put those, but I can see that the domain is broken up at -2. And then in between, let me think how to do it. X is less than -2. At -2 and at 1. So see how there's like this in-between part? That one goes there. And then that last one would be when x is greater than 1. X is greater than, okay, so I think I've got it right. So I've got, basically I can say 1 goes there. 2 is this little middle part. 2 would be in between that little part of the domain. And then 3 is right here. And then I just have to figure out what the equations are, which, oh, it's hard to see the pencil. Finding out the equations can be hard. So it's kind of hard to see what I marked. There's 1, and then 2 I just left red. 2, and then 3 is green. So I'm just showing how it has the different domains. So now I have to find the equations. So I can tell that 1 and 3, those ones are linear. And so is this one, it's a straight line, but it's a flat line. So it's at y equals something. So it's a different kind of equation. So in order to find the equations when you're given a graph, you can extend the lines using a ruler. And just like I did for graphing, it's kind of like backwards. You want to find your y-intercept and your slope. So I'm going kind of quick, but I just want you guys to see how you would do this. So my b is 3 for the first one, and my m, my rise over run, it looks like it's going down 1 over 1. I want to make sure down 1 over 1, down 1 over 1. So that would be -1 over 1, which is just -1. So that's actually how you get your equation. Y equals mx plus b. You plug in for m and you plug in for b. Okay. So my equation would be y equals, m is -1, so -x plus 3. Okay, and then the middle function right here, it's at y equals 5. So that's really all it is. It's just y equals 5. And then the last one, I need to extend the line again so that I can get my y-intercept. Let's see. Whoops. I recommend you guys try this in your book if you can. So I can see it has the same y-intercept, b equals 3, but its slope is different. So I'm going to count my rise over run for that one. So starting from my y-intercept, I count up 1, 2, right 1, up 1, 2, right 1. So 2 over 1 or just 2. So that would be y equals 2x plus 3. And this is kind of messy looking, so I'm going to just write my final answer for the function. I'll use pen since I'm pretty confident. You can write f of x, like how the other ones have been written, equals, and then it uses a bracket to hold it together. There's 3 of them, so I'm going to try to write it like the examples above. So like it has the equation, and then for whatever the domain is, whatever the x values are. So the first one is negative x plus this one, negative x plus 3. And then it's 4. So I'm just copying how it's written above. For x is less than negative 2. And then my next one is right here, y equals 5. So I guess you just write 5 for negative 2 is less than x is less than 1. So the more we do this, you'll get the hang of how to write the domain. And then the last one, y equals 2x plus 3. So I'm just going to write 2x plus 3 for x is greater than 1. Okay, and that's pretty much it. It's kind of complicated, but that at least gives you a good introduction to how to do this both ways. So this is how you have a piecewise function and you write the function. You have to break up the domain and see what each equation of each line, or it might be quadratic or whatever. So you get those equations and then you write it all together nice and neat. That's how you do that part. And then the other ones is what we did in the notes, where you have the piecewise function and then you graph them. All right, so finish up your notes, get your questions on the left in a summary, and there will be one more day where we practice these. Make sure you turn the notes into Google Classroom.